So let's look at something a little bit different. We have the graph of y equals log base of b of x passes through the point 8, 2. What is the value of b? So we're given some information that we're going to have to substitute back into this equation. So x is 8 and y is 2 based on this coordinate point. I'm going to substitute those into my equation that I'm given. So y is 2 log base b, and then x is 8. I'm going to actually turn this into exponential form. I think that's going to be the easiest way. So it'll be base b squared equals 8. Now the opposite of squaring something is square rooting. So we're going to square root both sides. Now we've introduced that square root. So it's going to be b is equal to plus or minus the square root of 8. The problem is we have a rule of logarithms that says the base must be greater than 1. So therefore, our base must be equal to 8 due to this rule right there. Now we're almost done. We should simplify this as much as possible. So we can divide this by 4. So I get square root of 4 times square root of 2. And therefore, I get my answer as 2 square root 2 as my base. Example 4. What are the x and y intercepts of y equals log base 2, x plus 4? All right, you've done this lots since grade 10. So for my x-intercept, I'm going to let y equal 0 and solve. So we have 0 equals log base 2 of x plus 4. Well, I'm going to go and turn that into exponential form. So 2 to the power of 0 equals x plus 4. Well, 2 to the power of 0 is 1. So then we get 1 equals x plus 4. We're going to subtract 3 off, or 4 off both sides. We get negative 3. So therefore, our x-intercept is at x equals negative 3. Okay, that's not so bad. Let's look at the y-intercept then. So here we're going to let x equal 0, and it'll be y equals log base 2 of 0 plus 4. So we get y equals log base 2, 0 plus 4 is 4. Now we could probably solve this one in exponential form, but it's probably going to be a bit easier to turn this into exponential form. So 2 to the power of y is equal to 4. We can do a common base, or you can think 2 to the power of what is 4. But if we want to show all of our work, it's going to change of base here. So 2 squared, so we have a common base of 2. So therefore, y is equal to 2, which therefore our y-intercept is at y equals 2. On to example 5. So what is the equation of the asymptote for y equals log base 3, 3x minus 8? Well, this question, there isn't too much to it. The biggest problem here is that this is 3 times x, meaning we need to factor that 3 out. So it becomes log base 3, and then 3 times x minus, I don't know what 8 divided by 3 is, so I'll just leave it as a fraction. Now our asymptote is always based off of our horizontal translation. And in this case, our horizontal translation is 8 over 3 right. So therefore, our asymptote is going to be at x equals 8 over 3. Easy as that. Okay, let's look at one more example where we have to find something that's missing. So the point 27, 3 lies on the graph of y equals log base b of x. If the point 4, k exists on the graph y equals b to the power of x, then what is the value of k? Alright, so our biggest problem here is we don't know what b is. We don't know what the base is. However, we do know on this logarithmic graph, this point exists on it. Well, 27 is our x value and 3 is our y. So from that, we can find the base. So I'll do some substitution. Y is 3, log, we don't know b, and then x is 27. Now I'm going to turn this into an exponential form then. So we have b to the power of 3 is equal to 27. The opposite of cubing something is cube rooting. So we'll cube root both sides. And we get b is equal to 3. So therefore our base is 3. So we can go to this exponential form where we have y equals 3 to the power of x. And we know this point is on the graph. So we're given what the x value is. We're asked for what k is. So I can even erase this y and put k. And so we get k is equal to 3 to the power of 4. So therefore, k is equal to 81.